The Moon, as Earth's satellite, has been the focus of space exploration since the dawn of the space age. Man first set foot on the surface of our neighboring planet on July 20th, 1969, during the first manned lunar landing of Apollo 11. The detection of water is of fundamental importance. As a building block of life, it could have enabled extraterrestrial beings, but also plays an important role in further space exploration as well as in proposed colonies on the Moon. The following video shows you observations of various research programs over the past decades that led to the detection of water on the Moon. Research programs of the 20th century. As early as 1961, researchers Watson, Murray, and Brown of the California Institute of Technology speculated about the existence of water on the Moon. As a result of the Apollo program, rock samples were collected by astronauts and brought back to Earth, in which investigations revealed traces of water. At that time, the research assumed the moon rock had been contaminated, since the surface of the Moon was considered at that time completely dry. In March 1971, during the Apollo 14 space mission, the first direct evidence of water was detected when the mass spectrometer of the space capsule registered the emission of water vapor ions from the lunar surface near the landing site of Apollo 14. Scientists Markov, Akhmanova, and Dementev from the Vernadsky Institute of Geochemistry and Analytical Chemistry published a paper in February 1978 in which they formulated the discovery of water with quite certainty. Their studies were based on lunar rocks brought to Earth by the Luna 24 spacecraft in 1976, in which a very small amount of water was detected by spectroscopic examination. Another indication of ice on the Moon came in 1994 from the Clementine spacecraft, a joint project of NASA and the Ballistic Missile Defense Organization. Clementine used radio waves to investigate the regions at the South Pole of the Moon. These waves were picked up on Earth by the dish antennas of the Deep Space Network, a global research network of satellite dishes for communication with satellites and space probes. Although the polarization of the waves was characteristic of an icy surface, the test results remained inconclusive and were therefore questioned. Radio surveys from Earth identified an area around the Moon's poles that is permanently in shadow, and therefore there is a chance that there are ice deposits in an area of 8,700 square miles. The Lunar Prospector spacecraft, launched in 1998, was able to conduct further investigations with its measuring instruments. It had a neutron spectrometer and was thus able to measure the amount of water vapor in loose lunar rock, also called regolith, in the polar regions of the Moon. In this way, hydrogen in the range of 50 ppm, parts per million, and an increased hydrogen concentration at the poles of our neighboring planet could be detected. Researchers interpret the results as evidence for hydrogen bound in minerals or ice in the always overshadowed lunar craters. NASA researchers estimate the expected amount of ice on the Moon at 0.6 to 1.9 cubic miles, and base their statements on the results obtained by the Clementine and Lunar Prospector probes. At the end of the Lunar Prospector's mission, it was allowed to fall purposefully into the Shoemaker crater, and the scientists hope for new discoveries in such a way. The crater is located near the south pole of the Moon, and the crash was supposed to release measurable amounts of hydrogen. The last exploration of the Moon satellite in the last millennium was on August 18, 1999, during a flyby of the Cassini-Huygens spacecraft, which provided incomplete data and no new information about water on the Moon. Research programs of the 21st century. After the turn of the millennium, observation of the Moon by the Deep Impact spacecraft continued in 2005 and experienced a setback due to incomplete data regarding the presence of water on the Moon. Radar investigations by the meanwhile demolished Arecibo Observatory in Puerto Rico in 2006 showed that the findings by the Clementine probe could not be ice, but rock fragments. This would also put the evidence of water vapor from the Lunar Prospector spacecraft in a different light and suggest a source other than ice for the water vapor. The data from the Arecibo Observatory nevertheless offers room for interpretation for the existence of water in the craters lying in the shadow of our moon. This assumption was confirmed by the measurements of bound hydrogen during the next flyby of Deep Impact in 2009. Only the probe of the Indian spacecraft Chandrayaan-1, which was brought down in a controlled manner in Shackleton Crater in November 2008, was able to provide clarity. On its 25-minute descent, the probe's altitudinal composition explorer detected water in the thin atmosphere of the Earth's moon and hydroxyl absorption in reflected sunlight. NASA confirms the existence of water on the moon. On September 25, 2009, NASA announced that water is present in large regions on the surface of the moon. The deposits are small concentrations of hydroxyl groups bound in the soil of our neighboring planet. The findings are based on measurements made by the Cassini-Huygens and Deep Impact probes with their spectrometers over the last century, and by the Moon Mineralogy Mapper on the Indian spacecraft Chandrayaan-1. On images from the Moon Mineralogy Mapper, the spectral signature of hydroxide is indicated by blue areas. The reflected infrared radiation from the sun shows the brightness of the lunar surface and is indicated by green areas on the imagery. Red areas on the photos taken by the Moon Mineralogy Mapper indicate the existence of the mineral pyroxene. Although the measuring results are consistent with those of the measuring instruments on board Chandrayaan-1 and show water molecules in the regions around the poles of the moon, thick ice layers below the lunar surface cannot be assumed. It is much more likely that they are pieces of ice about 4 inches thick associated with the loose lunar rock layer, the regolith. Additional results by the Moon Mineralogy Mapper were published by NASA in 2018 and suggest ice deposits around both poles. In addition, the Moon Mineralogy Mapper's capabilities to measure absorption in the overshadowed regions of the moon were used to detect ice on the moon. The measurement results show that the ice is concentrated in smaller patches at the North Pole, but is distributed in a larger ice surface at the South Pole. In March 2010, radar surveys aboard Chandrayaan-1 detected more than 40 craters lying in shadow in the region around the moon's North Pole that could hold up to 600 million tons of ice.